All right, welcome everyone. We're going to have a look at hang over here then. We're going to have a look at using or testing Docker-based images. Barely on. Okay. We're going one, two, one, two, one, two, one, two. Very sensitive, but okay. From the beginning, right? Welcome everyone. We're going to be talking about trying to test Docker-based images, and we're going to, in our test setup here, we're going to have a Wi-Fi server that is to mic it. One, two, one, two. All right. And again. So, all right, welcome everyone. We're going to be looking at today, we're going to see how we can test container-based applications with Docker. And the thing we're going to our setup is going to be, we're going to have one Wi-Fi server, and we're going to have our application that is going to talk through JPA to a MySQL database. And our first code there is going to just see what we actually need to do to be able to test that kind of thing. So in the beginning, we of course need to communicate with the Docker server, and somehow we need to know this Docker host machine IP. We need to know where that's located, so that's probably going to be externalized in some file. Then we need to start composing our images. In the first case here, we're going to create an image based on a MySQL database. So we've got to set up all the export paths. We've got to set up all the port bindings and the likes. And then we're going to build that image, and then we're going to start it on our Docker container. The next image we need to build, we're going to take in the Docker file to build a Wi-Fi image. Similar to the MySQL, we need to set up the port bindings, we need to set up all the extra stuff. And when all that is good, we have started those two containers, the two Docker containers. We want to connect to the Wi-Fi server that's running now on our container. We need to figure out what's the new IP address of our Wi-Fi server, connect to it, and then we need to create some form of deployment by creating a zip stream, essentially, that we can send over to that server. That's all of this stuff, essentially. And then we need to deploy it, which is the bottom little line here. And that's a whole lot of code to just actually get the containers up and running. But that's just part of it. That's before we can actually run anything at all. So we were going to try to test a persistence-based test. So when the test is running, if we magically manage to get inside the container somehow, we need to look up the user transaction, we need to get the entity manager, then we need to clear the database, insert the data, and control the transactions. So all this code is just setting up our database for us. And then essentially, when the test comes out, we need to look up in the bean manager to find our repository so we can essentially test. That's what we're trying to actually test here. Those two lines. That's the only interesting part from a testing perspective. All the other stuff is just CRUD. So let's see how we can tame the microservice testing with Docker and Arquillian. So I'm Aslak Knutsen, the project lead of Arquillian. I'm a senior software engineer at Red Hat. You can find me on Twitter on Aslak Knutsen. First thing we're going to talk about is Arquillian Core. Arquillian Core is essentially a testing platform. It's not a testing library. We're not trying to be JUnit. We're not trying to be TestNG, but we integrate with all of them. And one of the core points is to be able to execute this test from wherever you want to execute it from, that being your build system or your IDE. Arquillian is built in a sense that it's flexible and extensible, so they can add on different extensions and get new features essentially that are test-based. And we make our tests portable, so we're not binding you to specific environments. Arquillian Core is in a sense also built up of extensions upon extensions. So the first one is Arquillian Test, an abstraction layer between the different test frameworks. Support things like JUnit, TestNG, Spock, and Cucumber. With just Arquillian Test, there's just an easy way to make an extension work in all of these different test frameworks. And then there's Arquillian Container, handling the container lifecycle and deployment, and works with, or have adapters for Wildfly, JBoss, Tomcat, Jetty, and Tommy, and all the other application servers per se. So let's see if we, can you hold it? Thank you. So let's see if we try to apply Arquillian Core to our base tester essentially, and see what that will do. So we're going to start out by just applying the JUnit integration for Arquillian. The only thing you do is add the run with Arquillian on top, and that hands over the execution to Arquillian. And Arquillian Core on its own does nothing more than that. Just now you have a base for other extensions to build upon. So that wasn't too interesting. But let's add the container extension and see how that changes this base test. With the container extension, we can now remove all the stuff that had anything to do with the deployment, the zip creation, and the connecting and deploying to the app server. All of that now it's been handled in the background. So Arquillian provide now the deployment method with a shrink wrap API. We can easily package up all the different classes and so on you need and have that deployed to a server. And then conveniently, it also adds support for injection of different type of resources. So now, instead of looking up through JNDI, you can easily access the user transaction, the entity manager, the bare repository. We still need to do Docker stuff, and we still need to set up all of our database. But still, we can get some of our resources more easily accessible. So,
have you seen in the Arquillian Core and Arquillian Container, you're storing the container and putting there the test and executing the test and so on. And with the advent of the Docker usage, we, the Arquillian team, thought that maybe we could add a new approach of testing. If your test is going to be run inside Docker on production, your code is in Docker, we could even write your test and run it in the Docker infrastructure. So your test runs inside your application server and also inside your Docker infrastructure. But also, maybe you cannot use your code on production, but you decide to use Docker for your test. So for example, if you need a database, you can start a database in Docker and execute your test against this database. My name is Alex Soto. I'm the CleanCube lead. I work in CloudBees, and you can follow me in Twitter or follow in GitHub. So basically, what is Arquillian Cube? Arquillian Cube manages the life cycle of Docker containers. It means that when you want to execute your test, the first thing that it does is start a container on your Docker host, execute your test, and after that, close the container. So if you need, for example, a mail server, you can start a mail server before you execute your test, and your mail server will be containerized inside Docker. Also, if you want, you can use the application server that is inside the Docker container. And in this cases, what it's done is uses the Arquillian remote adapter, which means that you start an application server inside Docker, and then Arquillian itself will take your WAR file, deploy it in your remote application server that is running inside Docker, and it will execute all the tests. But also, Arquillian Cube helps you in orchestrating the containers, because probably your application it works inside an application server, but that also needs a database, an ML server, maybe a GMS servers, and so on. So you can define with Arquillian Cube all the containers that you will need it, and start all of them in the correct order. But the thing that the good abstraction of Arquillian Cube is that since it uses Docker, and Docker is like an abstraction of what's inside, so you can use your application server, but if you want, you can use non-Java applications as well. For example, this Drop Wizard, Spring Boot, Netty, all of them are from Java or VertX. It's for, and you have Node application, which is for JavaScript. And since everything is encapsulated inside Docker, you can still use Arquillian for applications that are run in different languages than Java or Java EE applications. So as you can see now, the test has been reduced a lot by using Arquillian Cube. Notice that there is no code about Docker management anymore. All of the code is managed by Arquillian Cube. You still have now the problems with having to clear the database, insert the database, start transactions, and so on. But as you can see, there is no Docker code here. So with Arquillian Cube, we have reduced a lot of code that was here before.
All right, so the last bit of this clumsy test is testing with persistence. So basically our microservice is a beer repository which lets you see the strongest beer in the world and some other stuff. And the last bit which we need to simplify is how to deal with the persistent tests. So my name is Bartosz Majsak. I'm Arquillian persistent lead. I work for Cambridge Technology Partners based in Switzerland, even though originated in Massachusetts. You can follow me on Twitter if you like, or see what I'm doing on GitHub. I joined Arquillian in, I think, 2011. Before that, I was doing, like I do now, a lot of Java-based web applications, and most of them are doing something with the storage. And one of the cases was obviously to store it in the relational database, let it be through plain JDBC, Spring JDBC templates, Joke, or JPA. So as I said before I joined Arquillian, I was using different tools for that. So namely DBUnit, which is a tool letting you seed your database through different formats such as XML, Excel, CSV, and so on. But it still have quite a bit of boilerplate you need to write. So then I discovered another library which is called Unitils, which brought a lot of good ideas which then I incorporated to the Arquillian persistent extension. So what really is an Arquillian persistent extension? First of all, it manages the life cycle of your database. So first, it's gonna clean your DB. You have several strategies to do it, so that you will start from the known state. Each and every test will be executed from the clean DB. Then you can seed your database using DBUnit dataset formats. On top of it, all the formats I have mentioned, we also support YAML and JSON. And then the other thing which we provide is ability to verify your datasets through the same DBUnit files, which is quite handy when you, for example, have to, let's say, reproduce some bug from production and you deal with a large volume of data. It does not really make sense to write some manual assertions in the test. You just take the sample file and you verify if your DB looks exactly like you are expecting it to be. And on top of that, we also provide transactions so that your test will be executed in its own transaction and you don't need to do it by hand. So we can actually have a look at the final version of our test code. And as you can see, there is no noise, there is no boilerplate. The only thing you have is actually the core of what you are testing. So the using dataset annotation will take any sort of DB unit file, will seed it to the DB, and then your test will be executed within the transaction. And at the end, instead of writing manual verification of the DB content, we can actually use a file to match the DB content against the YAML. So yeah, as you can see, there is no boilerplate. It's pretty much reduced from, I don't know, like 500 lines of horrendous code to like 50 lines. And you can focus on what really matters. So you write the test and you don't care about the boilerplate noise anymore. Yeah, that's pretty much what's cool about Arquillian. So we can actually run the test to prove that we are not only showing code, but we have something which runs. So what will happen here is we're gonna start Docker, hopefully. Underneath, we will start Whitefly, and the second container with MySQL. They will be both linked together. The deployment will go to our Whitefly instance running in Docker, and then the database will be seed in the MySQL container if demo gods will stop messing with us. The beauty about this test, by the way, is that there is no notion about the target environment. You don't have any information if it runs against Whitefly, if it runs against any other container we support. And yeah, there is also no notion about the underlying database. Everything is done in the portable fashion. So can we run the test, or we can't run the test? You need to trust us that it works. Or we keep trying. And in the meantime, you can ask some questions. Aslak will try to fix his Docker machine. Any questions? Okay. So we keep trying. Okay. All right, demo gods. Hopefully on Thursday when we're gonna have our real talk, it's gonna be working smoothly. So we have a talk on Thursday at 2:30. Don't remember the room though, but we're gonna figure it out. So